All right, geometry students, I am out for a few days, so while I am out, I've put together some video lessons for you guys to kind of keep things going with Chapter 6 while I am gone. So today we got 6.2. All right, and Chapter 6 is all about polygons. We're going to be taking a look at different types of polygons, looking at the properties of those, and then using those properties to solve some problems. Okay, so here we're going to be taking a look at what are the properties of parallelograms, and then we're going to solve some different geometry problems involving that. All right, so let's take a look at what a parallelogram is. So it falls under the category of a quadrilateral, which means it's going to have four sides. All right, is a four-sided figure, and it has two pairs of parallel sides. All right, so that would end up making a parallelogram. We use this symbol here to show that we have one, as we can see here with parallelogram ABC. All right, and take a look. Our opposite sides are going to be parallel, okay, as we can see here. And this is typically what a parallelogram would look like, all right? But there's also other figures that fall under the category of a parallelogram, all right? We'll take a look at what we have here. One of them is going to be a rectangle, all right? Rectangles also meet the definition of a parallelogram because they have two pairs of parallel sides. All right, another figure that would also qualify to be a parallelogram would be a square. All right, if we take a look at a square here, it has the same thing. Opposite sides are parallel. And another one that fits under that category of a parallelogram would be a rhombus. All right, and a rhombus is just a square that has kind of been pushed over a little bit. So a rhombus has all sides that are congruent, just like a square. So all these sides would be the same. All right, and they also have opposite sides that are parallel. Okay, so this is typically what a parallelogram looks like. Here's just some other examples of figures that would also be in that category. All right, so let's take a look at some properties of parallelograms, and then we'll start solving some problems with them. Here's the first one. We've just talked about this on the other slide. The opposite sides of a parallelogram are going to be parallel, but then they're also going to be congruent to each other. Okay, so side AB is congruent to CD, and CB would be congruent to AD. All right, opposite sides are congruent. Another thing we have with parallelograms is that opposite angles are going to be congruent. All right, so this is noted here in color. We got AC is going to be congruent to each other, and BD will be congruent to each other as well. All right, another property we have is consecutive angles will be supplementary. All right, the word consecutive means next to. All right, so angles that are next to each other are going to be supplementary, which means they're going to add up to 180 degrees. All right, so we're taking a look at A and B. They're next to each other, so they are going to be supplementary. Same with B and C and D, and A and D. All right, we got examples of each one of those right here. And the last property we have is that the diagonals of a parallelogram, okay, so here is our two diagonals of it, are going to bisect each other. Okay, so that word bisect, we've seen that a lot in semester 1 geometry. That means that these two line segments are going to end up being congruent. So BZ will be congruent to ZD, and AZ will be congruent to CZ. All right, and we kind of see that right here. They've written that down for us. Okay, so those are our properties we're working with today. We're going to take that stuff in consideration to solve some different problems that we're going to have. All right, so here's the first one we got. They're giving us this parallelogram over here. It's parallelogram CDEF. They're giving us some pieces of information about it. We're told that DE is 74 millimeters, so we can go ahead and label DE as 74. We're also told that DG is 31 millimeters, so here we have DG. We can label that as well. And the last piece of information we have is angle FCD. So this angle right here is 42 degrees. All right, so this whole entire thing, all right, is 42 degrees, the whole entire angle. Okay, we can take that information along with the properties of parallelograms to find out these pieces of information we're trying to solve. So we want to figure out what CF is. So we're going to use the property that says this side is congruent to this opposite side over here. So CF is also going to be 74 millimeters. All right. The next thing we're taking a look at is we're trying to figure out what angle EFC is. So EFC is this guy right here. So these two angles are consecutive. So that means they're going to add up to 180 degrees according to that property. All right, so these two angles together make 180 degrees. We know that this one is 42 degrees. All right, subtract that, and we are left with 138 degrees for this angle right here. All right, so EFC, 138 degrees. All right, and the last thing we want to figure out is what is line segment DF. So that would be this whole entire diagonal itself. And the properties of parallelograms say that this angle or this diagonal is being bisected. So DG is going to be exactly the same as FG. All right, so both of them are going to be 31 in length. So we can add the two together, and that'll give me complete length of DF. So we end up with 62 millimeters for DF. All right. So now that we've worked that out, I'm going to give you guys one on your own to try and see what you guys can come up with for this problem right here. Okay, you got this parallelogram that's kind of part of this whole entire basketball hoop and backboard here. All right, pause the video, see what you get for some answers, and then we'll take a look at your answers in a few minutes. All right, let's take a look at what you guys came up with for these. All right, so KN should give us 28 inches. Angle NML is going to be 74 degrees. And LO, the length of LO is going to be 13 inches. Okay, here's some justification on why that works down here. All right, LM and KN are going to be exactly the same. So they're both going to be 28 inches. These two angles are also congruent. So angle NML will be 74. And because LN is being bisected, LO is going to be half of LN. So LO is going to come out to 13 inches. All right. Okay. So now that we've solved a few of them, we're going to throw a little algebra into the mix here and figure out what we would get out of this parallelogram here. Some of it is labeled for us already. We want to first calculate what is the length of YZ using this information here. Okay, so a parallelogram says that our opposite sides are going to be congruent. So these two sides are going to be exactly the same. So if we label that, WX is going to be congruent to YZ. All right, so we can use that property to go ahead and set ourselves up an equation to get this thing solved. So we're going to say for Wx, we're going to fill in 6a plus 10. And that's going to be equal to YZ, which is 8a minus 4. All right, so there's our initial setup. Now we're just going to go through and solve this algebra problem. So we can do a double whammy to this one here, which means we can go minus 6a to this side. And it's like doing two steps in one. And we can also cancel this 4 out at the same time. So plus 4 to this side. And what we're left with is 14 is equal to 2a. All right? And if we continue working out the math, we end up getting 7 for a. All right? But we're not quite done yet, okay? Because this isn't the final answer. We still need to calculate what is yz. All right? So we need to put 7 in for a and figure out what we get. All right? So we're going to take and do that. We're going to take 8 times 7. And then after that, we're going to subtract 4. All right, so that's going to get me 56 minus 4, which is going to end up with 52. Okay, so that's going to get us the length of YZ, which is 52. All right, next we're going to calculate what this would come out to. We're trying to figure out angle Z, which is going to be this guy right here. And looking at our properties, these two angles are consecutive, which means they're going to add up to 180 degrees. All right, so we're going to take these two sizes for these two angles and make them equal to 180. So our equation is going to look like this. We're going to have 18b minus 11 plus 9b plus 2, and that has to equal 180 degrees. All right. Now we'll just go through our steps. We're going to combine all the like terms that we have. So we can combine 18b and 9b together to get us 27b. We can combine negative 11 and 2 together to get us minus 9. All right, and that's all going to be equal to 180. All right, now we're down to a two-step equation. So we are going to cancel out 9. And we get 27b is equal to 189. All right, last step, divide by 27. All right, and that's going to get us b is equal to 7. Okay, so fantastic. We've solved for b. We're not quite done because we still have to put our answer for b into this problem and see what that angle size actually is. So we need to go 9 times 7 plus 2. So if we do that down here, 9 times 7 plus 2 is going to give me 63 and 2. 65 degrees. All right, and that would be our final answer for that right there. All right, that's how you go about solving those ones. I'll have you guys try one on your own, see what you come up with, and then we'll take a look at your answers once you get finished. All right, pause the video, try this one, and we'll check out what you get. All right, let's take a look at what you guys would have gotten from this. So for this one here, you're working with the diagonals. So you got to use the properties that have to do with the diagonals of a parallelogram. Okay, so this is what we end up with. JG is going to give us 12 and FH is going to give us 18. All right, here's our setup for the first one. We go through, we solve it. we end up getting 4. We plug 4 into our equation, and we get 12 for the first answer. All right, here's our setup for B. All right, these two pieces are equal to each other. So we fill in the parts of our equations. We go through the steps, solve for that. We get right here. We divide by -2. We end up with z equals 4.5. So then we can plug 4.5 back in for z, and we end up with 9 for that. All right, hopefully that worked out for you guys. We got one more piece to take a look at, and then we're going to be done with this lesson here. Okay, so the last thing has to do with plotting a parallelogram on a coordinate grid when we have 3 of the points and we need to plot the last and final point. All right, so we just want to make sure that where we plot this point is going to make it an actual parallelogram where opposite sides are going to be parallel. Okay, so step 1, we graph the points that we have. Okay, so this has already been graphed for us. All right, and then an easy way to do it is just take the 2 points, any 2 you want to. I usually use the 2 that are closest together. That's usually simpler. And I just want to figure out what the slope is for those 2 points. All right, so I just want to find my rise over run, and that'll guide me to get my final point put down. Okay, so to go from K to L, I'm going up 1, 2, 3, 4, and I'm going over 1, 2, 3, 4. Okay, so I'm going up 4, over 4. I'm going to follow that same pattern down here for J. So I'm going up 1, 2, 3, 4, over 1, 2, 3, 4. All right, and that would be my location for M. All right, M is going to be at 7, -4. All right, simple as that. You could draw the whole thing out to make sure you have yourself a nice parallelogram, see if it actually works. It's looking pretty good to me, so it's good to go. All right, there's some math we could do to calculate this to verify that we actually got it, but if you are following that same slope, then you should be just fine. All right, try one on your own, see what you come up with. Okay, take a look at this one. You got 3 of the points. Get that last one on there, and then we'll take a look at what you guys got. All right, let's see where you guys ended up putting point R. All right, point R is going to go... Let's see, hold on. Are those 2 separate problems? Nope, that's good. My coordinate grid just moved up. All right, so point R is going to be at this location here. So we're looking at 7 and 6 for point R. All right, so it would live at that coordinate there. All right, and then there's your slope to find where that would be. All right, I hope that worked out for you guys. Next time we'll get jumping into 6.3. Let me get your guys' assignment up there for today. All right, that's what you guys got for today. And we'll see you guys next time in class.